welcome to the stage Microsoft Technical Fellow and Chief Technology Officer at Azure AI, here to talk about a holistic representation towards integrated AI. Please welcome Xuedong Huang.
Hello, I'm XD Huang. I'm a Technical Fellow and the Chief Technology Officer of Azure AI and Microsoft. I'm presenting from a virtual stage prototype that's powered by Azure Cognitive Services. I lead a global team of scientists and engineers building AI to extend the human capability. In 1993, I left Carnegie Mellon University to found Microsoft's Speech Technology Group. Today, I lead Azure Cognitive Services team, creating AI that's comprehensive, modern, state-of-the-art. In today's presentation, I would like to share the update on a few of our services and some insight into where I think the future progress will come from. I will introduce cognitive services and share our amazing journey in the development of our core AI capabilities for all developers worldwide. So here is the introduction diagram of cognitive services and the ecosystem. As you can see, the core Azure Cognitive Services got the foundation model and the customization layer. Right now, we have foundation model for each pillar, from speech, vision, language, all the way to OpenAI's GPT model. And we are using those APIs to enable both horizontal applications and the industry-specific applications to take full advantage of our AI capability to transform their application. So here is the story behind the scene on the journey, how we developed core AI breakthroughs that got integrated into cognitive services in the form of API to delight people like you. We were the first to reach human parity with humans in speech recognition on the switchboard that has been worked on for almost 30 years by the whole research community. Then we got a sequence of breakthroughs from machine translation, image captioning, to the most famous superglue, natural language processing. So breakthroughs like this can be combined into the API to improve the usability and the horsepower. So I want to reflect the journey beyond Microsoft in improving cognitive services. The Economist magazine published this review in 2017 that's still insightful. So in the review, they really talk about a few key milestones and highlights. The first one is really statistical model that was pioneered by speech research, especially like Jim Baker from his PhD thesis and the CMU. That was the first work using hidden markov model for speech recognition. And then Microsoft and Jeff Hinton worked together to get deep learning into speech system that demonstrated tremendous value, then got broadly adopted in computer vision and language processing, including translation. So you can see now the foundation model is becoming the mainstream. It was popular with Google's transformer that was developed for translation. And then BERT is actually a subset of the translation capability in the encoder-decoder architecture. Microsoft Unified Speech is actually unpublished. It's in production. By combining different silos in speech, we actually created even better result, as you can see from this table, because of the power of create the foundation unified using all sorts of data from different domains, different tasks. And this has been in production in cognitive services since 2017. So the foundation model is now popular. I want to actually really share some of the journey on how we got here. In 1992, I was a faculty member at the Carnegie Mellon University. I wrote a proposal to National Science Foundation about the unifying acoustic model and the language model. Those are those pink boxes in the speech recognition system. 30 years pass quickly. You can see the whole system, not only the speech system from the combined acoustic model and the language model, but also signal processing, decoder, adaptation, as well as the downstream tasks such as translation and summarization can be created with a unified transformer with the end-to-end optimization and foundation model. That is how the whole community pushed the envelope, modernized the whole recipe. In addition to the component unification, we have seen the unification across multiple languages. So Microsoft delivered the Z-code mixture of expert in production as part of the document translation in cognitive services. In addition to just using the encoder-decoder architecture for parallel data for translation, as most people have been using, we are also using the monolingual data, essentially combining the masked language model as used in BERT, as well as traditional translation with the same encoder-decoder architecture. With multitask optimization, we're able to create a massive model supporting 100+ languages, dramatically improve the quality of Microsoft cognitive services. As you can see from this x-axis, this is a set of language pairs. On the left, you can see high resource languages such as English, French, and German. On the right, we have some low resource languages. With Z-code, taking full advantage of monolingual data and multilingual data. By combining all those data together, it's amazing. We see the benefit across the board, whether they are high resources languages on the left or low resource languages. So this is already in production to enable people taking full advantage of our modernized AI horsepower. So now let me share with you a demo. This is multilingual translation system by combining speech and the translation all together using unified transformer. This is not in API form yet, but it's a prototype. I want to illustrate the power of unified optimization end-to-end. You can speak multiple languages, and the same spoken signal can be translated into multiple languages at the same time. So it's multilingual in, multilingual out. Here's the demo.
Hi, I'm Laura. Nice to meet you. In this series, we're going to learn basic German expressions. It's super easy and it only takes 3 minutes. In this lesson, we are going to learn how to introduce ourselves in German. We'll start speaking right away, but first, it's important to clarify that in German there is a difference between the formal and the informal language. Let's first see how German people introduce themselves in an informal situation. Hallo, ich heiße Laura. Schön, dich kennenzulernen. Hi, I'm Laura. Nice to meet you. Hallo, ich heiße Laura. Schön, dich kennenzulernen. Start by saying, Hallo, ich heiße, then say your name. Hallo, ich heiße Laura. Finally say, schön, dich kennenzulernen. Hallo, ich heiße Laura. Schön, dich kennenzulernen. And now, let's see the same sentence in formal speech. Guten Tag, ich heiße Laura Meyer. Schön, Sie kennenzulernen. Good day, I'm Laura Meyer. Nice to meet you. Guten Tag, ich heiße Laura Meyer. Schön, Sie kennenzulernen.
Using similar encoder-decoder transformer architecture, we can make small changes instead of optimizing for the multitask objective function for masked language model and the translation as we use for Z-code. We can optimize just for summarization. By doing this one, we expanded Z-code into Z-code++, and one of the industry open research benchmark like XSum, every line in this chart is a system submitted by a wide range of companies and the universities. As you can see, Z code plus once again is leading with the human overall benchmark. So we are in the process of integrating Z code plus into cognitive services in the form of API that you can take full advantage of to save time for everyone. As you can see, we have created a foundation model for speech, for translation, for summarization. We could use the similar transformer architecture for computer vision as well. We created Florence. That is the foundation model for computer vision. Before Florence, computer vision task is very diverse, very challenging. So we just created the many silos for each service, whether it's image classification or image captioning or object detection. We create many silos. What is even more challenging is when the developer is using one of the APIs, they might just use the API for slightly different scenarios. It's not robust enough. And the cost of customizing is very expensive as well. So we turn this into horizontal layer by using a massive amount of data, using both image encoder and the text encoder. We introduce the semantics into the computer vision foundation model. Then we added an adapter on top of the foundation model for a wide range of different tasks. With this new architecture, we have the first foundation model to demonstrate amazing quality for 40+ research benchmarks. In this graph here, every line is a research benchmark that is open to be participated by university or companies. So whether it's image classification, image retrieval, object detection, or video and language task, Florence foundation model offered us amazing improved quality. So this is the back-end technology we are in the process to integrate into cognitive services API, just like summarization and speech translation to serve the customers worldwide. Now, I want to share with you how Florence can interpret a video with bounding box and the corresponding semantic interpretation in the form of language. Then the second video is to pass the Florence output in the form of text into summarization that could identify the key frame. Then we can put the summarized information together, pass that to a neural custom voice with the talking head, not via me, but generated by AI to tell the story as almost like an AI anchored XD.
This scene takes place in the Kruger National Park, where a rhino is walking down a dirt road next to a safari truck. In this scene, a rhino is walking down a dirt road next to a vehicle. The man in the safari vehicle is driving next to the rhino.
Okay, we had the overview of cognitive services with foundation model in speech, language, and computer vision. And on top of the foundation model, we can easily customize the driver adoption. Now I want to talk about the future roadmap. What is challenging? You can see that from neuroscience research, we have observed that humans are more intelligent than animals because we have no pattern separation. This means we use the same set of neurons to store all the information about different modality. Therefore, we can connect the dots. We can leverage transfer learning to be smarter than animals, which got the pattern separation. They use different neurons to save different information. So with that in the backdrop, we have been pursuing integrative AI, what we call XYZ code, in the past few years. This is a holistic representation of creating text, sensory, and multilingual information seamlessly all together. So you can see this has the business implication. We are a global company. We want to serve all customers worldwide. That's why multilingual is an important dimension for us to serve our customers. Language and sensory is either audio or video. That intersection is what we are trying to jointly optimize. In that Venn diagram, we have even bigger circle. That is about using external knowledge to further improve the horsepower of the foundation model, because all those transformers only use the self-attention that lacked the external knowledge. So we believe that self-attention plus external attention with joint optimization of different modality along XYZ dimension will give us the needed AI capability for the next generation of cognitive services. So we have started pursuing XYZ code, or we call this I code, stands for integrative AI. And we achieved the state of the art on some of the most challenging multimodal AI tasks that involve speech, vision, and the language. In addition to create better AI APIs, we believe that customization, how to land this with customer, is equally important. Let's take the example of Microsoft OCR and form recognition. In cognitive services, we have the ability to offer OCR or handwriting recognition supporting 160 languages. Actually, by the end of the year, we'll be able to cover 200 languages. The form recognition augmented the foundation model of language with the pixel information. So the layout structure information can be taken into account. So we have the foundation model for form recognition. We also have the customized model for different verticals, such as receipt, invoice, etc. So for customers to take advantage of our AI capability, they still need to customize further for enhanced quality and improvement. So we have been fortunate to partner with Snorkel AI to leverage their amazing labeling capability for form recognition. Our solution used the Snorkel AI's auto labeling capability to automatically label fields with pipeline management fully integrated, so new custom AI can be easily trained and created for our customers. These new AI models can be deployed in the seamless framework with Snorkel's simplified end-to-end automation, and the model development cycle can be further improved. So this is just one of the examples how Azure Cognitive Services can work together with ISV and partners to make AI's adoption simpler and faster. DOS was the command line-based interface introduced by IBM, and in the early 80s, it's popular. Xerox PARC created the graphic user interface in the 70s. So they took advantage of the graphics card and the mouse, stitched all those capabilities together. Both Apple and Microsoft recognized the amazing beauty of GUI. That is the GUI moment I referred to. This revolutionized computer interface forever. Today, with speech foundation model, Z-code, computer vision, GPT-3, DALL-E, etc., all those APIs are available in cognitive services. We believe the whole community, the industry, reached the moment to create the next GUI moment using integrated AI. And all those APIs can really transform the industry in a profound way, just like what GUI did. This is the opportunity that we should work together to really transform the industry for all walks of life. It's an amazing opportunity. So to conclude, Microsoft's mission is to empower every person and every organization on the planet to achieve more. We believe AI is in the front and the center to fulfill the mission, to transform the industry. Thank you.
What an amazing talk. And I think I echo the audience's sentiment that those were some really, really cool demos for us to get a sense of what Azure AI is working on. So we have time for maybe just one question. And so to answer our questions, I'd love to invite to the stage Principal Research Manager at Microsoft Cognitive Services Research, Chenguang Zhu, here to answer questions. Welcome, Chenguang. Thank you for being here with us.
Hi, everyone.
Amazing. So just one quick question for you. Would love to hear, I mean, you've done extensive work in NLP in terms of various different data sets, question answering at Squad, Fever, like fact verification, a variety of use cases, and now you're working on large language models. Just curious to get your thoughts on, what do you think? Some people think large language models, GPT-3, just solve every problem, and they are very impactful, but just trying to get a nuanced view of what do you think are some of the shortcomings of large language models, or even some cases where they work really well. But just, your thoughts in general there.
Well, yeah, thanks for the question. That's a great one. So actually, recently we looked into this area because we see a lot of new research results coming out. For example, say large models like GPT-3, Palm, got state-of-the-art results in few-shot learning, in context learning, meaning given a few examples in the prompt, in the input prompt, it can generate very good predictions. But on the other hand, if we do have a lot of label data and we want to conduct the full fine-tuning, we find that the medium-sized model perform really well and even better than these super large language models like BERT, Roberta, T5, these models. So recently we wrote a paper and published on Archive called Impossible Triangle, arguing that currently, if we look at the domain of language models, no single model can simultaneously achieve these three desired properties. First is moderate size, meaning it's, let's say, less than 1 billion parameters in the current scenario. Second is you can achieve state-of-the-art results in context of few-shot learning, given a few examples can do well. The third is achieve the state-of-the-art results in fine-tuning if we have enough data. Because in business, we find that the moderate size means we can deploy it efficiently. In some use cases, we don't have enough data, right? Especially for like small customers who don't have enough budget. But for some cases, especially big customers, they have enough budget to label. They just want to achieve the best results. Right. But currently, we don't see a single model can achieve all of these. So one of our core tasks is to develop such a model that can achieve these three desired qualities and properties at the same time to facilitate more business scenarios.
That's very fascinating. That's like, these models are few-shot, but if you do have more data, a smaller model does work better compared to these really, really large models.
Yeah, at this stage, yes.
Amazing. Well, thank you so much for that very interesting insight.